Hello, everyone, and good afternoon. Thanks also for joining us for this second webinar. Today we have Dr. Rebecca Gordon, who will speak to us about memory. I would like also to thank Michelle and Erica for coordinating this series with me. And I would like to thank Educational Neuroscience Hub and the University of College London, the Institute of Education, and the Faculty of Education for organizing this series of 7 webinars. Later on during the webinar, I will be sharing with you a Google form so that you can use it for attendance purposes and eventually for certification. As you know, if you attend 5 of these 7 webinars, you will be entitled to this certificate of participation. I can leave the floor to Erica and eventually to Michelle to introduce Rebecca.
Oh, we can't hear you, Erica.
Muted. So first, I would like to thank you, Rebecca, for accepting our invitation to give an overview on the relationship between learning and memory. I'm looking forward to this webinar. As mentioned last week, our aim in organizing these webinars is to create awareness and a better understanding of the development of the brain within the context of teaching and learning. And more importantly, they also aim to create a bridge, a common language between science researchers and practitioners, as well as parents, enhancing evidence-based strategies. And more importantly, awareness and knowledge on the science of teaching and learning will encourage schools to build an evidence-based system for teacher preparation so teachers can select instructional strategies more likely to succeed with today's students. Thank you. Hope you enjoyed this informative talk on memory. Michelle, on to you.
Yes, thank you, and welcome, Dr. Rebecca. Just a little brief information about the specific webinar. Children who are able to sustain their attention, process information quickly, and maintain that information generally perform much better in school than children who have deficits in those areas of cognition. In this session, we're looking at how we know what we know about learning and memory by reviewing developmental neuropsychological evidence, for example, case studies of people with traumatic brain injury. We then look at how such information might be used in the classroom to develop learning strategies that aid recall and to understand how children who struggle may be assisted by compensating for specific deficits. Something about Dr. Rebecca Gordon now. Dr. Rebecca Gordon is an associate professor and director of the Motor Executive Cognitive Interaction, MECI lab at UCL Institute of Education. She's a cognitive psychologist who is a chartered member and associate fellow of the British Psychological Society and a member of the management committee for the Center for Educational Neuroscience. She also runs the ESRC accredited MSc in Developmental and Educational Psychology at UCL. Her research focuses on memory and executive function as it relates to academic outcomes such as reading and mathematics. She is also interested in the relationships between executive functions and dyslexia in children and adults. On to you, Dr. Rebecca Gordon. We look forward to hearing what you have to tell us.
Thank you. Thank you, Michelle and James and Erica for the introductions. I'll just explain, if you hear panting, it's my dog who's suddenly decided to wake up and come into my study. So I'll try to make sure he doesn't disrupt things too much. So yes, we're going to be talking about memory and then taking what we know about memory so far and applying it to the classroom in terms of how it might help us and the children in the classrooms. So first of all, let's look at a simple question, which is what is memory, which sounds like a simple question. And some of you may be aware of this diagram here, which says that memory is something happens in the environment, we sense it in some way, we hear it, we see it, we touch it, etc. And then if that information is not attended to and is not relevant, it is then lost. Then we have short-term memory, where information is available for up to about 30 seconds. And if it is not stored in short-term memory, if it's not rehearsed, then it will transfer to long-term memory. I'm sorry, I don't mean to interrupt my talk, but is this being recorded? I didn't recall anybody pressing the record button. It doesn't matter.
Yes, yes, it
Oh,
is.
It
is.
Great. Sorry, I just I'd promised some colleagues. Sorry about that interruption. So that's sort of what commonly many people think memory is, but it's actually not quite that simple, like most things. So let's look at how we know that it's not quite that simple. So first of all, we'll look at, if anybody has done any psychology, they're most likely aware of the curious case of Henry Molaison, who was actually known as HM up until his death in 2008. So Henry Molaison was born in 1926 in the States. When he was about 7 years old, he had an accident on his bike, on his push bike. And shortly after this, he developed severe epilepsy, which they think they can attribute to the bicycle accident because he sustained a head injury. So this epilepsy became more and more severe, so that by the age of 27, it was life-threatening. He was having several grand mal seizures a day. And so they decided to perform surgery on the area of the brain that was causing the epilepsy. So he had a bilateral hippocampal lesion, which basically means they took out his hippocampus. Now, if you go straight in from your ears or into the center of your brain, approximately, that's right in the center of the brain, you'll find these two like seahorse-shaped structures, which are the hippocampi. And these, we now know, because of this poor man, are responsible for the creation of new long-term memories. Because after this operation, he was unable to form new long-term memories. And I've put "or could he" in brackets, but we'll get to that in a minute. So he couldn't remember. He could meet you, talk to you, you go out of the room, come back a couple of minutes later, he would swear that he'd never ever met you. He couldn't remember what he'd done that morning, the night before, the day before, a week, a month before. So he couldn't create these new long-term memories that we form all the time. So it was very sad. He was cared for by his parents until they died, and then in a care home. And he died in 2008. And so important was the behavior as a subsequence of his operation that his brain was donated to the Brain Observatory in San Diego. And thinly sliced, he donated it willingly, thinly sliced, so they could see exactly where these lesions were in his brain, which caused the subsequent behavior. So that was Henry Molaison. Now let's have a look at Clive Wearing, which is actually an even sadder story. Because Henry, if you see videos of Henry Molaison, he's in and of himself, he's fairly happy, but this was not the case with Clive Wearing. So Clive Wearing was born in 1938 in the UK. And when he was in his 40s, he contracted viral encephalitis. So encephalitis, basically, in very basic terms, what it does is it eats away at the neural connections in your brain. So you lose certain functions if you contract this virus. Now, he suffered from the encephalitis severe damage to his left and right temporal lobe and the frontal lobes, and it completely eradicated his hippocampus. So after this, similar to Henry Molaison, he was unable to form new long-term memories. And he had also, because of the damage we now know to the temporal and frontal lobes, he had very, very almost non-existent short-term memory. So this is the ability to hold information in mind for up to about 30 seconds. He would attempt to keep a diary, and he would write one sentence, and it was usually "I am awake." And then he would cross it out because he would swear he never read it, because he couldn't hold information in mind that long to know that he'd just written that sentence, like not even a second before. He described it as constantly, oh, I'm sorry about that, that's my alert on my iPad, as like constantly awakening from a state of unconsciousness. So it was pretty awful case, but it did teach us a lot about memory. He also had, because of also the damage to the temporal lobes, retrograde amnesia. So Henry Molaison only had anterograde amnesia. So he lost the ability to form new long-term memories. But Clive Wearing had that and also retrograde. So he actually lost a lot of memories that were formed before he contracted encephalitis. So memories stored in his brain were also eradicated for decades before. So what does this, why were these case studies so important? What did they tell us about memory? Well, it wasn't just what these people lost, but it was what they retained. So both of them completely lost their hippocampus. But Clive Wearing could still learn by repetition. So for example, he could watch videos like a film over and over again because he'd never remember having watched it. But after a few repetitions, he would start to be able to anticipate in an event in the film. Even though he would say, I've never seen this film before, he would say, oh, that woman's going to do this next. So he was able to learn by repetition. He was a pianist and he retained that skill. So he could still read and play music, which again is another form of learning. Henry Molaison still had his short-term memory, unlike Clive Wearing. So he could still remember, he could hold a conversation, he could do a crossword, but then he would see the completed crossword and swear he had never done it. But he could, because he could hold information in mind for short periods of time. He could also learn new motor skills at the same rate as normal controls. And I'll just very briefly describe to you what I mean. So there's a difficult task, and you're probably familiar with it or something similar, where you have to draw a star, a 5-point star, but you can't see your hand drawing the star. You can only see your hand in the mirror drawing the star. So you have to actually push the pen in the opposite direction. And when the first time you do it, it's quite difficult because the intuitive way to move the pen is in the direction of where you want to draw, but you have to do it in the opposite direction. But if you do this a few times, you actually get quite good at it, and then you develop the skill to do it in the mirror. Now, Henry Molaison could learn that skill just as quickly as people without brain damage, without damage to their ability to form new long-term memories. Even though every time you brought the task out, he'd swear he'd never seen it before, he could actually learn that new skill. Also, his priming and conditioning abilities, which are also a form of learning and forming of memories, were not impaired. So, for example, a conditioning task. A lot of you will know about Pavlov's dog. So you can do something similar with people. So you might get somebody to rest their chin on a piece of apparatus, and then you put a puff of air in their eye, which of course makes them flinch and pull back. If you then pair that with a beep, what happens after a few pairings is that when people hear the beep, they flinch and pull back because they've got this paired association. Well, Henry would habituate to that task just as quickly as people without hippocampal damage. So he had conditioning, he could learn new skills, he had short-term memory, and he could learn priming and conditioning. He also could learn new spatial layouts. So several years after his injury, they moved house. So they moved from the family home to a new house. And after a period of time, he learned where the bathroom was, where the kitchen was, where his bedroom was. So he could still form new long-term memories, but he couldn't form a very specific type of long-term memory, which we will get to shortly. Then we have another important case study, and others subsequently, but these are the ones that in the early days of understanding memory were very important. So this is the patient KF. I don't know whether KF is still alive, but he was at the time of this study, which is why we're still using his initials. He had a motorcycle accident which damaged his left parietal occipital region. Okay, so we had temporal lobe damage, the others and frontal lobe damage, and some occipital lobe damage, and also the hippocampal region in the middle. And KF had damage to the parietal occipital region, so here. So he had very, very poor short-term memory. So he could, normally we test short-term memory by saying to people, I'm going to say a series of letters and I want you to repeat them back to me. And he would usually remember 1, maybe 2 letters. So really, really poor. He couldn't hold information in mind for short periods of time. But when we, I wasn't part of this, when they did recognition tasks with him, so if you remember with Clive Wearing, he had still have recognition abilities. When they did recognition tasks with KF, he could actually learn new word sequences, actually in fewer trials than normal controls. And he still could retain those items in long-term memory for several months. So what's important about this and the Henry Molaison and also the Clive Wearing study is we have a thing that neuropsychologists call double dissociation, which is where you can lose one ability but retain another, and then have another case study where somebody loses that ability and retains the other. So basically you can have one ability without the other, which means that memory is not unitary. It's separable. It's overlapping, but it's separable. So now we know that memory is very, very complicated. And it's even more complicated than this, but I have kept it very, very simple because this is not, a science lesson and we want to get to the classroom. So memory can be split to long-term memory and short-term memory. Long-term memory can be split into declarative memories and also procedural memories. Procedural memories consist of things like skills, habits, perceptual priming, classical conditioning. Declarative memory has episodic memory and semantic memory. I'm going to show you in a minute what I mean by the difference between those two things. And then short-term memory is what makes up a large part of one of the two types of memory we're going to talk about today, which is working memory, but I'll leave that for now. So let's have a look at types of memory. So if I said to you, what is the capital of France? And then I might say to you, when did you last ride a bicycle? And then I might say to you, how do you ride a bicycle? Now these represent three quite different types of memory. Now, I'm not saying they're completely separate because it's more complicated than that, but roughly they represent three different types of memory. Because if I say to you, what's the capital of France? Then I would say that all of you would say Paris. It's Paris. You might have just been to Paris and it might evoke a memory of it. Maybe a visual image or a feeling or something that happened to you. This is where it overlaps with another type of memory that I'm going to talk about in a minute. So if I said to you, when did you last ride a bike? Or if you don't ride a bike, when did you last see someone ride a bike? This is a very different type of retrieval, which slightly overlaps with this if you've recently been to Paris type memory. Because if you think about the last time you rode a bike, you might think you're not just going to remember it was on this day. You're going to remember a number of other things, probably where you were going, if you were with somebody else, what the weather was like, what time of year it was, whether it was pleasant and not pleasant. It's a form of mental time travel. And this is called episodic memory. So when you have something like this, if you just recall what's the capital of France, Paris, that is what we would call semantic memory. It's just a fact. And it's not something that evokes not necessarily, unless you've recently been there, it doesn't evoke all these other types of memories for the context in which you experience this. And then we have something else. If I said, how do you ride a bike? Well, I'll just give you a spoiler. We don't actually know. Well, as of 2016, we don't know. We know how bikes can balance by themselves, but we don't actually understand how people stay on bikes. It's a very complex motor skill that so many of us master very, very quickly and never ever lose. But my point is not that. My point is that when you get on a bike, you don't think, okay, so I need to get on, I need to put my foot in that pedal and my foot in that pedal, and then I need to push down on that, and then this pedal will come up, and then I have to push forward. You don't do any of that. You just get on and ride it. That is a skill, but it's still something you've learned. It's still something you've formed a memory of, but it's a very specific type of memory, one that is not explicitly recalled, one that is implicit. So this is all to say that memory is complex. But we're going to talk about two very particular types of memory today. One is declarative, and we will talk about episodic and semantic memory intertwined because we're going to talk about learning in the classroom. And you'll see why I'm intertwining them when I get to the activities we're going to do. And we're also going to first talk about working memory. And the reason we're talking about those two things is what we want to discuss is how we go from learning something to remembering it so that we can recall it when we need it. And so we're going to talk about, as I said, working memory, specifically how we pay attention, how we process information, and how we store it, because those are basically the functions that sit within working memory and that enable working memory. And then we have long-term memory. And long-term, we can talk about many, many, many different ways in which children can encode information that is beneficial to them, but we don't have enough time. But I have got a resource for you to look at it yourself, a very accessible resource. So we're going to talk about context, elaboration, and recall. But let's first talk about working memory. And the reason I've put this picture of somebody with the frontal lobes lit up is because the frontal lobes are very implicated in working memory. So we know they're important in working memory because we know when people get damage to the frontal lobes, it impairs their working memory and the associated skills. But it's not located just there. It's a complex network throughout the brain, but they are very important. So first of all, we're going to talk about filtering information. And we're not going to talk about it first. I'm going to actually get you to do it. So none of these tasks require a pen or paper. In fact, I'm expressly saying do not write anything down. You need to do this all in your head yourself. Okay, so what we're going to do is I'm going to show you a row of words, 3 different rows of words with 1 word at a time. Now, what I want you to do is say out loud to yourself the color the word is written in. So not the word, the color it's written in. Okay, so here we go. I won't call them out because that'll make it easier for you. Okay, ready? And I'll do them about 1 per second. Okay, so I would say that you found that pretty simple. You just looked at the color of the word and you said it. Okay, so now let's try it again because it was quite a simple task. It should be even more simple the next time you do it. Ready? The color the word is written in. Okay, now I'm going to guess that that was a lot more difficult. I'm just looking in the chat to see whether anybody, I don't know whether the chat is enabled, is it? So I can't, no. But if the chat was enabled, I would say that people would agree that that second one was a lot more difficult. Now, this was because you had to ignore information that was relevant to the task. So what do I mean by that? So obviously in this trial, the color the word is written in does not match the word itself. So when you did this trial, sorry, I have to go back, which was quite simple, you didn't have to inhibit or ignore the actual word green in order to know that that word was written in green because they matched. But when you go here, you have to, your automatic response, I bet, was to read the word red. So you have to go green, oh, sorry, yellow, red. So there's a slight pause before you actually complete the task, before you actually do what you've been asked to do. And this is because you have to filter out information that is irrelevant. And this is an important part of working memory. So I'm going to go through, I'm going to explain the different components of working memory and then bring them all together so you can understand it as a construct, but then also see what it looks like in the classroom. But this is a major part of it. And some children find it more difficult to ignore irrelevant information than other children. And if that is the case, then their working memory can be impaired. And that causes problems in focusing instructions and learning to read and learning basic numeracy skills. All of these things rely on working memory. So let's look at something else that is important in working memory. So just to let you know, I'm going to get you working a lot through this presentation because I want you all to experience these things. So switching attention, right. So what you can see here is a bunch of faces. They're all smiling, and some of them have long hair and some of them have short hair. And then you see some faces here, and they're all unhappy faces, and some of them have long hair and some of them have short hair. Now, first of all, we're going to have a very, very simple task where I just want you to say out loud to yourself whether the face you see has long hair or short hair. That's it. And again, about 1 per second. Okay, fairly simple. Now I just want you to say out loud to yourself whether the face is happy or sad. Ready? Very, very simple. But now we're going to make it more difficult because you'll see the face displayed on the screen, and there'll be a line in the middle of the screen, a horizontal line. And if that face is above the line, I want you to say whether it's happy or sad. If the face is below the line, I want you to say out loud to yourself whether it's got long hair or short hair. Okay, ready? Now, I would say that you found that more difficult because you had to do a number of things. You had to, in part, you had to focus your attention on the rule because you had to maintain that rule in mind. So you knew above the line or below the line, what was the rule? And then also you had to switch your attention to an aspect of the face, you know, whether you were looking for the hair or whether you were looking to see whether they were happy or sad. And this is switching attention, and it's something else that is very, very important in working memory. And some children are impaired. You can imagine children with ADHD are impaired in this switching of it, this ability to switch their attention. And if that is the case, then they can have impaired working memory, which of course has downstream effects on their learning ability. So let's look at something else. We've looked at the filtering out of irrelevant information. We've looked at this ability to switch attention. Now we're going to look at the processing and storage. And more of you may be familiar with this task if you weren't at the others. So I'm going to show you 5 digits, and each one will be presented for about 1 second. And when they've all been presented, no writing them down, just try and remember them in the correct order. Okay. Right, so see whether you can call them out to yourself in the correct order. Now we're going to try 6 digits. Right, and again, see whether you can recall those 6 digits in the correct order. Now we'll try 7. Okay, some of you should be starting to fail now, starting to not be able to remember them in the right order. 1 more go, 8 digits. Right. So I'd say many of you failed then, but I would say something you were all doing was verbally rehearsing. You were trying to maintain, as it kept updating another digit, you were rapidly rehearsing, probably subvocally, the string of digits in your head so that they didn't decay, so that you could still remember them at the end. What this shows is that ability to maintain information in mind is limited. And this is another aspect, obviously, of working memory. But it is very limited for everybody, even for adults. There is only so much information we can keep active in our mind for even a very short period of time, even for 30 seconds. And we use strategies such as verbal rehearsal, etc. And children struggle with this. Well, everybody struggles with it, but some children with specific developmental disorders struggle with having a limited capacity, and that could be for a number of reasons. They may just have not enough cognitive resources in terms of attention to maintain the information in mind. They may have poor strategy generation, so they may not actually think, oh, if I rapidly repeat the numbers, I won't forget them. And that, of course, has an impact on their learning, which we'll talk about later. So I'm going to add some complexity to it so we can now start to think about what this might look like when you are receiving information that has meaning to it. So we're going to start off very simple, that I'm only going to do 2 trials of this. You'll see 2 sentences, and I just want you to say to yourself, yes, if you think it makes sense, you know, like if it's a true statement, and no, if you think it doesn't make sense. Okay, so no writing down, just say it to yourself. Ready? Right. So I would say that you said yes to the first sentence because water is wet, and no to the second sentence because a bed cannot fly, unless you're in some film from the 70s. But now, what was the final word of each sentence? Now you can probably remember in the first sentence it was wet, and in the second sentence it was fly. But now let's try it with 5 sentences. Okay, the same deal. Just say out loud to yourself whether or not it made sense, and then we're going to try and remember the last word of each sentence in the right order. Ready? Okay. So you probably said out loud, no, yes, no, yes, no, in terms of whether the sentences made sense. But I will have to trust you as to whether or not you could remember the final word of each sentence. Now, you may well have been able to do so. And while you were doing so, you were probably trying to search for cues, for what was the meaning of the sentence, trying to remember what happened. We'll talk a bit more about that later. But this, again, the point here is that there is a limited capacity. So that task is more aligned to measuring working memory than the previous simple digit span task, because it has more complexity to it. So you have to process and store information concurrently. So what is the point of me getting you to do all these exercises? The point is to show you that working memory is something that you use deliberately. So you actually go, okay, I'm gonna focus here. I'm gonna process this information. I'm gonna store it. I'm gonna filter out information that isn't relevant. Maybe somebody's fidgeting next to you, or there's a dog making noise in the other room. And you're going to focus your attention to whatever aspect of the task is relevant to actually be able to complete that task. So you're actually switching your attention around at the same time. And hopefully you can see how this ability is so important in the classroom. Now, I know that working memory is spoken of in the UK. I don't know about the system in Malta, but in the UK, I think working memory is introduced when teachers learn their have their initial teacher training. But the detail isn't often there. And that's why I wanted to break it down into these different aspects to make sure that it's truly understood how many things can actually go wrong in working memory, how many things can actually be impaired that can result in a child having very poor working memory, which makes it very difficult for them to understand instructions and acquire skills in the classroom. So let's have a look. I mean, I know this isn't a typical learning task in a classroom, but it's just to demonstrate it in a sort of an education-based example. So if I said to you, calculate the following, 5 minus 3, and then take that result and multiply it by 6, and then divide that by 4. Okay, you would no doubt come up quite quickly with the answer 3. But there's a lot going on when you do that, you know, if you have established skills, you probably don't even think about it. But I want you to bear in mind everything we just talked about in terms of the filtering out irrelevant information, switching attention, processing, and storing information. So what do you have to do first? That's easy. You have to subtract 3 from 5, sorry, which equals 2. Okay, so you've processed that information and you've got your result of 2. But then you have to store 2. then you have to switch your attention away to go, what did we have to do next? Okay, we had to multiply it by 6. Okay, so now I have to go and retrieve that 2 from memory and multiply it by 6. Now that gives me 12. 2 now is no longer relevant. So let's inhibit that. Sorry, I'm using technical words. Let's filter out that irrelevant information because we don't need 2 anymore. So now we've got 12. Now I have to remember 12. Now I need to switch my attention back and go, what do I need to do next? I need to divide by 3. So now I need to go back and recall that 12 and I need to divide it by 3. By 4, sorry. Now 12 is no longer relevant, so that needs to be filtered out. So we divide 12 by 4 and that equals 3. So you think you're there, but you're not, because you have to think, was there anything else I had to do? No, there wasn't. Okay, then the answer is 3. Now, if you think about working memory and those different components of it, you can see there are multiple places in which a child can struggle. Attention, filtering, storage, processing, etc. So impairments, working memory is important in any novel or demanding task. So for adults and children, when you're in a novel or demanding situation, you need this deliberate and effortful ability that is limited, very limited. So when you're learning new information, following instructions, and children are reading, learning to read, and then also reading, learning maths, learning science, etc. This all relies on working memory, paying attention and processing information in the classroom and filtering out the child fidgeting next to you, or the teaching assistant in the corner who's doing a fun task with another child, etc., etc., or the rain, or whatever it is. And this by no means is a definitive list, but I just wanted to summarize some literature that shows that different populations have problems with different abilities that rely on working memory. So ASD and dyslexia and developmental coordination disorder, we know that they have problems with planning. Autism spectrum disorder have problems with flexible thinking. Prospective memory and dyslexia, verbal fluency in most of these developmental disorders, and verbal storage and dyslexia, and also Down syndrome, and inhibition is that filtering out of irrelevant information. I just want to stress this is not a definitive list. This is just some examples of literature that has shown that these populations have deficits in these specific areas. So it's not a domain general deficit. It can manifest in different ways. But I want to now, because I'm aware of the time, go on to long-term memory. Now, long-term memory, as you will remember from the diagram, it can be split into different types of memory. But let's just talk broadly about what happens when we learn something new. So you're sitting in a classroom, you learn something new. Something happens, so that, sorry, that's my dog. So the teacher starts to talk, it causes neurons to fire. You decide that hopefully that it's something important. So then the frontal lobes will regulate your attention to focus on the thing that's happening. So the teacher talking, which increases the firing. Okay, so this strengthens connections between neurons, which creates some, to simplify it, some trace of information. Then these components of the event, whether they're visual, acoustic, whatever, are analyzed. And they are associated, now this is the important bit, and you'll see why in a moment, they are associated with previously recorded events. So existing knowledge that we have. When we learn something new, it doesn't sit alone. It always connects to other information that we have in our memories, but also, like I said, about remembering the last time you rode a bike, that you might have about when the event occurred. So it's not just riding the bike, it's what the weather was like, how you were feeling, etc., etc. And then they are stored in long-term memory for later recall, hopefully, when you need it. So yes, where they are retained and retrieved, and each time they are retrieved, they are strengthened, they are further consolidated. I'm aware of the time zone. There are many, many things that we could talk about in terms of helping children encode information in long-term memory so that it is readily available when they need it. But we're going to talk about 3 things that we know work well: context, elaboration, and retrieval. So first of all, we're going to talk about context. So I'm just going to ask you, no writing down, just to remember these words, okay? And I'll read them out as I put them on screen. Smell, boot, toe, walk, soccer, shoe, arm, ankle, yard, mouth, hand, sock. Sandals, sorry, as well. So now I want you to say whether these words were actually in the list. Toe, flag, ankle, kick, inch, foot, boot, yard. Now, this is not a controlled experiment, so I can't guarantee that this will work, but ordinarily when I do this with a room full of students, some of the students, quite a few of them, will have said that flag, kick, foot, and inch were on the list, when in fact they weren't. Now, the reason for this is context. So many of the words presented are to do with, we've got boot, toe, walk, ankle, shoe, sock, sandal. So they're all things related to the foot. I put soccer in there, which might create some imagery of, or some memories of playing football, which of course is very much related to boots and ankle, etc. So then when you present another list of words, that, for example, flag, kick, and foot would have some related meaning, some overlapping meaning to those words. People often think that they were in the list too. And that is context, because when we're presented with information, like I said, it doesn't sit alone. It connects itself to other knowledge that we have. And this is important to know because it's not a bad thing, it's a good thing. It can help us. So let's look at something. Oh, right, so this was the actual list. Flag, foot, inch, kick weren't on there. So if you thought it was, it wasn't. Like I said, not a controlled experiment, so I can't guarantee it worked, but just to make a point. Right, so now I'm going to ask you to remember a different list of words because we're going to talk about elaboration. Lion, dog, donkey, shark, eagle, butterfly, rabbit, elephant, cat. Now, if I was in a lecture hall and I said to students, how many of those words do you think you could remember? There'd be mumbles, oh, most of them, some of them, maybe half of them, oh, I've already forgotten them, etc., etc. If I made you do another task and then came back to it, you'd probably say, oh, I don't know, I think there was an elephant. It's quite easy to forget that list of words. But let's try something else. So you don't need to read this. You can if you want, but I'm going to read it out to you. It requires slight amount of acting, so that's embarrassing for everybody concerned, but let's try it. So, oops, I can't see because, okay. So imagine a house. When you walk into the living room, there is a lion lying on the couch reading a book. There is a fireplace in the room where a dog is making cocktails. He's even wearing a waiter's jacket and a bow tie. Now you go into the kitchen and sitting at the table is a donkey playing poker. At the head of the table sits a shark, a card shark, a joke, all dressed up in his shirt and jacket, leaning back on his chair. On the stove is an eagle with his wings spread out. And the eagle is overlooking a table, watching the card game. The kitchen is pretty crowded, so you walk into the dining room. As you enter the dining room, there is a single butterfly perched on a chandelier. It's beautiful with bright blue wings. Below the chandelier, there is a big dining room table full of rabbits, and they're hopping all over the dining room table. There are so many rabbits that they keep falling off the table. And the last room on this floor is the bathroom. As you go in, you see a huge elephant sitting on the toilet. On the windowsill is a black cat stretched out in the sunshine. Like most cats, he's looking for the least crowded place in the house. He would dearly love to jump out of the window, but it's closed. So if I were now to test you, even if I got you to do another task and then come back to this, you would remember, I'm quite confident that you will remember a lot more in terms of the list of animals. If I said list all the animals in that story, you might not remember all of them, but you will remember many more than you would by a simple list. Now let's try one more thing. I'm not going to go through the whole story, but what if I presented it like this, like a storybook? In the lounge, there's a lion reading on the couch. In the corner, there's a dog making cocktails. You go to the kitchen and a donkey is playing cards. And at the head of the table, there's a card shark. If I went through the whole story like that with imagery or even video, I bet you could remember the majority, if not all, of the words. If I made that house your house, you would remember even more. Now, what is the reason for that? The reason is elaboration, because what we're doing is well, a number of things. We are connecting the new information to images and knowledge that you already have. We're also, but the most important thing about that example is we're elaborating. We're not just giving you one single boring word after another. We are creating imagery around it. We're creating emotions. We're creating a bit of humor, a number of different things, and even some spatial knowledge because you're moving through the house, which, when that information is encoded, gives you far more cues with which to retrieve that information when you need it. You're not just looking for a single word. There's a whole lot of other stuff that you've encoded with that memory, in the same way as when did you ride a bike and you're cycling through the park and you remember it was sunny and then you saw somebody you knew, etc. All that stuff helps us retrieve information. And of course, in evolutionary terms, this makes perfect sense. We want to be able to remember information, and we want to be able to remember where we learned it. It's going to help us. We want to know that those berries are poisoned, that over there is where the scary monster is that might eat us, etc. Simplified examples. But the single thing, which I can't do for you now because it takes a while and it's also not very enjoyable, is testing. Effortful recall of information is the single most beneficial way in which you can get children to remember new information. Doesn't have to be high stakes, doesn't have to be related to their grade, but it has to be effortful. Now, we're not quite sure why. There's still research into this, and I'm actually writing a theoretical review with somebody at the moment as to why recall might be better than elaboration, and by context, using different contexts. We're not sure why. I'm rushing a bit because I know we want time for questions, and I can see that it's nearly 10:02. I'm sorry. So the reason, very, very briefly, is that every time, as I said earlier, when you remember, when you effortfully recall information, it reactivates the neural connections that were activated when you first formed the memory, but also connections to the new context within which you're retrieving it. And this strengthens the associations and makes that memory trace more robust. So new information associated with established knowledge, and also the more personal, the better. Like, and I said, if that house I described was your house, you would remember those list of animals much more easily. So, sorry, this is just an example, some further information on how elaboration works. So associating words with other information, like the story and the pictures, creates additional associations. So children can use examples. If you want a child to learn a concept, get them to use an example, get them to explain it to somebody else, get them to combine words and visuals. All this helps strengthen that information. I don't have time to talk about all the strategies that children can use. Many of you may already be aware of this resource, but it is an excellent resource, the Learning Scientists. And they've done a lot more work in this area than I have and can provide you with a lot more information. So some tips very briefly. Working memory, it's effortful and limited, so don't overload it. Here's a fantastic example of a very poorly designed ticket machine at a station. Where do you even start with that to actually get your ticket? I'll let you look at that in your own time. Use short repeated chunks. So a shopping list is always a good example. I'm using adult examples. So a simple list of words doesn't mean much, but when you categorize into frozen food, dairy, bakery, fruits and vegetables, immediately it's a lot more easy to process and also to hold in mind for short periods of time. Unnecessary background noise is detrimental. So this is one of the biggest challenges I know teachers in the UK face because of space. There's often things going on in the corners of the classroom that don't have space for that, or staffing to do that outside of the classroom. But if you can minimize that as much as possible, that is a very good thing. And don't force unnecessary attentional switching. So I'm going to use my favorite example here for this, which is this. Any of you who've got a call while you're on your phone, and then you're like, okay, so this is making attention switch all over the place. So, okay, on the left, that means I can end this call and accept the new call. The one in the middle, which has the same symbol that I would use in accepting the new call, means I could not accept the new call, so I could decline it. And then the one on the right, I would hold this call and accept the other call. It's so complex. I don't know why it is designed this way, but that is a very good example of dividing attention. So reduce working memory load, break down information, reduce unnecessary background noise, and that's not just auditory noise, it's visual noise as well, and reduce unnecessary attentional switching. Long-term memory, use existing knowledge, encourage explanation, reframing, use mnemonics, rhymes, use low-stakes testing. And I'm sorry, I've finished in time for questions in 9 minutes. Sorry about the rushed ending.
Thank you, Rebecca. That was really interesting. Thank you so much. We've got some questions from the audience. In fact, we had a large audience today, similar to last time, close to 160 attendees today, similar to last time. So let me go for the first question. This is related to dyslexic children. So some dyslexic children have a good long-term memory, but a poor short-term memory. How can one help children in the classroom and at home to remember instructions? And there's more to that. Can you recommend some research? And what is the connection between the visual and the listening process in dyslexic children? I know that we have a webinar coming up with regards to dyslexia.
Yeah, I do. Well, I mean, just briefly, that because yes, children with dyslexia do tend to have an impaired working memory, which sometimes is referred to executive abilities or executive function, but they do have problems with following instructions, holding information in mind, and something very specific, which is remembering to remember. So prospective memory, remembering that at the end of the day, they need to do this, at the end of the class or the task, they need to do this. And the best advice I can give is to the things that I listed previously. So breaking down the information into smaller chunks, avoiding distraction. So you know that you're only presenting the information that is necessary, minimizing the amount of attentional switching that is required, etc., etc. And then also offering them external aids. Now, I don't see why this couldn't be for all children, but you know, there's SEN stuff on this, but I think that if you aid a child who struggles, you're not disadvantaging a child who doesn't struggle by giving them the same support, because they will take the support that they need, but that's a different story. So giving them external memory aids. So, and a lot of this is done anyway, you know, giving them mini whiteboards so they can write stuff down, allowing them to write something down so that they don't forget it, giving them support for processing information so that they can write down the first task, complete it, then the next task and the next task. So it's that kind of scaffolding that breaks it down to minimize the cognitive load. In terms of the connection between visual and listening processes in dyslexic children, that's a really big question, and I will be talking about it in my webinar. I think maybe it's best to save it until the next one, because that is, yeah.
Okay, so we have our second question. How does language influence long-term memory, especially when you are learning a second language?
Okay, so there's a lot of evidence. So there's two sides to this. One thing, there's a lot of evidence that language is very important in encoding information in long-term memory. And there's research with children who are pre-verbal and then verbal, and it's probably too complex to take too long to describe here, but we know that the point at which the child experiences an event, their language and vocabulary at that time will influence the degree to which they can remember that information, even later when they're post-verbal. So they've done experiences. Simcock and Hain is a very good example if you want to have a look at this. It's called the magic shrinking machine, but it's an event that a child plays this game, and I won't describe it because we'll run out of time for other questions, but it's very exciting and interesting and very engaging for the child, and will create a really, really nice episodic memory for them because it's visual and exciting, surprising things happen, and there's bells and things. And you can actually test children on this, 6 months later, a year later, and you can, because they are more likely to remember it. They won't definitely remember it. And what they have found is that the vocabulary the child had at the time of the event will dictate how the detail that they can remember. So even if a child didn't have the language to describe it at the time, they might remember the event if you give them the tools with which they can reenact it. But a child that has the right vocabulary at the time of the event can effortfully recall, so like use declarative memory to say this is what happened. So there is a lot of evidence that language influences long-term memory for events like that. But we also have to be wary that just because a child doesn't have the language to explain something doesn't mean they don't remember it. They might not just have the vocabulary for it. So it's a tricky area.
Exactly. Learning
a second language, I don't know much about it. I do know that there used to think that children who were bilingual had enhanced working memory, which in that literature is called executive function, because they have to have this ability to inhibit or filter out irrelevant information, maybe from their first language, and used in order to use and understand the second language. But that's not really thought to be a thing. The evidence has increasingly shown that they don't actually have enhanced working memory. But in terms of how that influences long-term memory, I'm not actually. So if you are, okay, so you're talking about learning it. I mean, there is lots of evidence that if you're learning a second language, as much imagery you can use as possible, like I did with, the story and the lion and everything, will help you remember the new information. I remember when I was learning French and we had to learn the action verbs, the ones that were reflective, and that we actually drew a picture of a house and drew little people doing different things so we could remember what all the different verbs were that needed to be conjugated in a certain way. So things like that do help. Sorry, that was a bit of a response.
In fact, you answered the next question, which asked, do storytelling and listening to stories impact memory? In fact, she mentioned, Laura, that whilst you were reading the story of the animals in the room, she closed her eyes to imagine the story, and she made her own imagery in mind, which helped her. And in fact, you answered her question, do storytelling and listening to stories impact memory?
Yes, that enhances memory because you're creating more personal memories because you're using your own imagination. And we know that more personal associations are more effective.
We had another Ivanka who said this was so interesting and confirms why some pedagogical methods work. And thank you.
Exactly. Sorry, just to say that's
yes, not
so
a
important.
problem.
It's making sure that teachers understand a lot of this you're already doing, and now you know why. So it's really good.
And you're just confirming it.
Yeah,
not a problem. Next question. We don't have a lot of time, but we'll go on to the next question. Are there significant EF differences between typically developing children and those with hearing impairments? In other words, does hearing affect executive function?
I've had this question before and I promised I would go and find out, and my answer is honestly I don't know, because I don't do research in that area. Sorry.
Okay, how can you help improve short-term memory in a timed test, for example in a mental maths test where you have to read the question very quickly and process it or work it out?
The evidence increasingly points to trying to improve short-term memory or working memory through training does not work. You might get better at a single task, but it won't transfer to other tasks that rely on that construct. So you're much better off using scaffolding strategies, reasonable adjustments for those children.
Okay, James, Michelle.
Yes, thank you, Rebecca, for a very interesting presentation. We've had a lot of questions. We're sorry we couldn't answer all the questions there. If you can just unshare the screen so that I can share the final slide. Thanks, Rebecca. What we'll share the next webinar, which will be held in 2 weeks' time. So this time we'll focus on the topic of facts and myths about dyscalculia. We'll have Jovan Herwegen with us. So later on, also today, we will upload the video recording of this session, and we'll also share the registration link for this next webinar. So thank you, Rebecca. I'm not sure whether Michelle would like to add anything before we close this webinar.
Yes, one quick comment. I felt quite anxious, Rebecca, with some of those mental exercises. It makes us realize how complex the brain is. And at the same time, there's always a rational explanation to why we don't manage to focus sometimes or to retain some information. And hearing you explaining this so coherently was very helpful to us as educators. So thank you indeed for this session.
I'm really pleased. Thank you. It was very enjoyable and a pleasure.
Thank you, Rebecca.
Thanks. Thank you all, and have a nice evening.
Yes,
Bye.
good evening to you all.
Okay.
Bye, thank you.